Yeah. So one of the big things that I know is really important when dialing in environments, and people is become more common knowledge, and people discuss it now more these days, is vapor pressure deficit, and just the content of vapor in the air and how that affects cannabis plants. Um, One of the main misconceptions I think that people have about temperature and humidity is often that these are just the almost like what makes a plant comfortable, but don't understand the functionality of how a plant actually absorbs moisture, and through the moisture, the nutrients and different compounds, and how that moisture then evaporates. It transpirates, leaf transpiration, through the stoma of the plant, creating an osmotic diffusion that transports nutrients throughout the plant. Um, and this is why vapor pressure deficit is so, or vapor pressure, the vapor content in the room is so important. What techniques, how do you go about optimizing vapor pressure deficit? And have there been any advancements and new things that come out? I was wondering if you could just kind of discuss that a little bit.
Sure, I'd say two things. I don't use any special technology for it really. I just kind of tend to try to follow the charts that are out there to keep the temperature and humidity in an optimal range to balance out that vapor pressure so that we're getting the flow of nutrients and water through the plant. Oh yeah, yep, through the plant at an optimal way. It's kind of, I think of it as like almost like a choke on an engine. It's, we have the CO2 is there available. Ideally it's in optimal levels itself. The water and the nutrients are down in the soil. The light is on and giving it energy that it needs in that way. But those things out of balance. The fuel, if the fuel isn't being fed to the engine in the right way, then it's not going to be optimized. And one thing I would say too is I feel like there are appropriate times to stray from vapor pressure deficit, and that, like, if we take it to there's one grow out in Denver that I walked through that kind of took it to the extreme absurd conclude to the absurd extreme of the theory, and they putting steamers in there, and it really earlier on in their life, yeah, they like more humidity and more heat, and I get it. But when they can get to the point where it's going to increase the chance of disease for the plant, and then also damage buildings. A lot of the materials of construction of buildings sometimes that end up having mold issues later and having trouble passing testing. But for the most part, I do try to stay within range. Yeah, mostly just using the charts and conventional controls.
What materials are being used to mitigate that risk of mold inside of a facility?
So I'm really glad you asked. Conventional cleaning goes a long way. Good SOP is probably the most important thing, because you can have a clean room facility, and if a trimmer scratches their head or touches their nose and touches bud, I'm not sure about all the places you've worked, but in Michigan the microbial testing is very, very strict. No cigarette would pass testing, no apple, no piece of candy. It's yeast and mold that's just ubiquitous in the environment that makes people fail. So sadly, I mean, very sadly, people are they're. It's not uncommon practice for some people out there to dip their buds in sanitizers, Sanidate, and hydrogen peroxide, and things that we don't know what it does to the plant, but I know it lowers the quality quite a bit. So I mentioned earlier the indoor environmental quality work that I've done.
Mm-hmm.
So an example of that would be an operating room or a lab where they're doing research, and they don't want someone to come in and say, well, it's straight 2 degrees, so we're calling into question the results. And so really some of the projects that I worked on, can keep it within 1 degree and 1% from spraying any cubic, inch within the whole room and all. That's labor intensive. It's, we don't have to go to quite that extreme with cannabis. But I do like to take some principles from that work. So, good, no stagnant water, no stagnant air. It's mantra. I've been around for quite a while. Good airflow, keeping the temperature and humidity in optimal ranges. But in addition to that, I use a special sanitizer. It's a food grade sanitizer. There are a few different ones that I use, but they're all food safe, hospital grade. You could, they're no rinse, so you could spray on a cutting board, cut some chicken, and serve it without rinsing, and it's good. They actually use some of these as mouthwashes. So I use, but it kills better than bleach. So I'll go
What's the
through.
compound?
One of them would be chlorine dioxide that I'd
Hmm.
recommend people looking into, and there's some brand names that will use that, and some other similar chemicals, but it's less irritating than bleach, and it kills just as good. And it's
Have you ever used silver solution?
I haven't actually. That's so there might be an application for everything, but silver is something that I would cite for my the next layer of protection I use is kind of like used in the same situations where silver is used,
Okay.
but I'll cite silver and some other things. So silver is actually a poison that leaches out into the environment, and I'm sure that some people have used it with good effect. So I'm not, no ego, and I'm open to being wrong, but I think my way is better, to be honest with you. So it lowers efficacy over time. So if it's embedded into a surface, leaching out into the environment, into the microbes, over time, it's going to lose concentration and efficacy. Also, when you're using a poison like that, or when you're using a substance like that, the microbes gain resistance. So they have a chance to gain resistance to it and become superbugs.
Yeah, mutate and become a superbug. Okay, I
Mhm.
never actually heard that before, so that's good. I used to make my own colloidal silver, right?
It's great for selfing some plants, of course, right? Or getting them to herm to self
Yeah,
pollinate
I
or
never
collect.
used it for that way. I actually was growing microgreens and I was spraying my seeds down to kill any bacteria that was on the seeds before I put them out.
Oh, well, you know, I
Interesting.
was on the other side of the fence, so that was my argument on why mine is better. And not in every application where there be complications like I listed, but the substance that I use, or the type of technology that I like to use after conventionally cleaning or having new construction, and then
Right.
sanitizing every surface, and then I go in and lay a surface coating down. It's actually similar to plant waxes, funny enough.
Cool.
Actually, I'll use this as the surface here. Actually, I'll flip it around. Get get Miles a stick around here. No, so
Give
if this
Miles a
is
plug.
here's
Shameless
the
plug for Miles.
yeah here's the surface, and then we lay down basically it looks like a bed of sorts molecularly. Each of these are like a chain of atoms that stick up from the surface, and
Right.
along the top of it, they all cross-link and covalently bond. And so the microbe comes into contact, and this is as durable as the surface you apply it to, because it's covalently bonded, like permanently bonded, as permanent as can be without extreme chemicals that would never be in a facility like this.
Mm-hmm.
And so, because of the electrical charge of these atom chains, molecular chains, when the microbes come to the surface, they get a little electrical impulse, they get electrocuted on a really small level, and they get ruptured. And under electron microscope, they look like, from grapes to raisins. And it bypasses that adaptogenic response, keeping them from getting the resistance, and continues to kill as long as the surface isn't worn away. So normally I'll reapply once a year or so, just for normal wear and tear.